either side of the planet, or 13 miles of bulge on either side of the equator that is greater than the circularity of the poles.
Okay.
That 13-mile bulge is what keeps all of the continents and everything basically in place. So, for instance, as we're a spinning ball like a top or whatever, instead of having we're not able to shift because the bulge would prevent, for instance, Africa from crawling north. Or North America from crawling south or going east to west because of the equatorial bulge basically holds everything into place. And so one theory is that as we go forward here, the bulge will flatten out, and thus we'll have what's known as a crustal slip. And that would be where all of the continents shift around and jerk and so on as they shift to a new position. This has happened in the past. How many hundreds and thousands of times, we don't know, but we've got evidence for a number of specific such occurrences. If you really want to look it up, go and read Charles Hapgood, The Path of the Poles, and some of those books that he references. So there's that theory, right?
Right.
That what's going to happen here is that because of the energies from the sun, the Earth is heating up in the middle like all of the other planets in the solar system and is exhibiting what we think of as anomalous behavior. It's not. It's perfectly natural for the solar system to do this at this particular time. It's just that we've never, as a species, encountered it and survived. Therefore, we think of it as something that, is new and interesting and unique and probably not good for us. And it may be all of those. We just don't know. But in any event, so if the Earth does become an exact sphere, in terms of its general overall shape, we find some really interesting things. Like we got this huge, heavy amount of ice on what we think of as the bottom, but that ice in Antarctica does not overcome the mass of the continents that is Eurasia. So given an opportunity, Eurasia would tend to fall towards the bottom, so to speak. It really doesn't matter whether we think of the North Pole as the top or not.
Right.
It would tend to shift based on our angular momentum, centrifugal force, etc. So we could expect that might occur if the bulge flattens out.
It,
And it seems to show some signs that it is altering, whether flattening or not. Now, there is an alternative. Let me bring this up. There's an alternative theory that is equally valid given the facts, including Hapgood's path of the poles, the shift of the continents, etc. The other theory is what's known as the planetary expansion model. And we need to stop and go back to my idea that we're all energy beings, right? We're all
right.
trucking around vibrating as standing waves of energy. Well, what are we standing on? We're standing on nothing that is solid. We're just standing on another form of a giant standing wave, which is the planet Earth. It's just a huge, giant toroid that's collecting and spewing energy for all it's worth. So it kind of makes sense that even if you were to take Einstein as being accurate, or even pre-Einstein stuff, where we say that energy and matter cannot be destroyed; they can only be converted from one to the other in our particular universe. Well, here's our situation: we're standing on this mass of energy that we call Earth, that we think of as matter, and it's receiving all kinds of new energies out of the sun that it hasn't had in these past 50, 80, 100, 200, 5,000 years. And it's got to do something with those. So maybe what the Earth is going to do is to take those energies that are zooming right into the middle of its toroid, which is basically the middle of the planet Earth, and maybe it's going to create new matter. And maybe that's where magma, our core, comes from, and so on. Bear in mind, the core of the planet Earth is not molten iron. That's a bunch of hooey. That's so far wrong. It's down there with the Flat Earth Society guy. The core of our planet, if it were iron, by the way, first off, no molten metal, even in a hyper-accelerated state, can be made to throw a magnetic field. We haven't been able to achieve it. It just does not happen. But so there's no way that the magnetism that is the Earth's magnetosphere could be created by a spinning chunk of iron in the middle of our planet. Now, it could be created theoretically by iron that was frozen. Once iron cools, or metal cools, it can take a magnetic charge. It's just that when it's hot, it can't.
Okay.
Or it can take the charge, it can't express it. So once the metal cooled in the crust of the Earth, theoretically that could provide the magnetosphere. However, science argues against that because our magnetosphere fluctuates constantly, and we know there's not enough metal in the crust to produce the level of magnetism that we see exhibited in the Earth. So what's the other alternative? Well, plasma, that is to say, super excited energy, throws off a magnetic field like nobody's business.
Hmm.
And so it makes a lot of sense that the middle of our planet is in fact plasma. And that plasma is basically, you can think of as just like really hot gases. Or actually what it is, it's energy in the process of becoming matter. So the sun throws off all this energy. It goes down into the middle of the toroid that is the planet Earth. Planet Earth says to itself, well, geez, I'm big enough, or I got all this stuff. I got to do something with this energy, and so it starts converting it to matter. And in the process, that's where we get oil percolating up through the crust and all of this, as all of the finer levels of molecule that are instantly created, the hydrogens and heliums and so forth, gradually become denser and denser and denser and clumped together as they are pushed out towards the crust. But you can imagine in such an idea that it would be theoretically feasible, and in fact a natural extension of that theory, that the Earth could expand itself.
Hmm.
If it got a big burst of energy from the sun and it didn't know what to do, it would just create a bunch of matter and it would expand from the inside out. So that theory still has validity, because that theory would say that when it expanded enough, the equatorial bulge would crack and disappear. Different process, but nonetheless would flatten out. That theory would also say that at that point, the continents could go spinning around, just
Hmm.
like in the other crustal theory. Plus, the planetary expansion model has one other thing going for it that is just cool as hell. And that is that if you were to take a globe or a giant spherical paper map of the Earth, and you were to take some scissors and carefully cut along all of the coastline and remove all of the areas that we think of as the water, the ocean beds, and so on, you would notice something, that all the continents fit together.
Right.
Okay, they snug together, but the size of the sphere is 60% smaller.
Hmm.
Okay, so it is quite feasible that we started out 60% smaller, and over the course of time, we got all these expansion incidents, and we expanded. And the what would happen in those situations? Well, you'd get a crack in the space between the continents as new matter is shoved up, and they would get shoved further apart. You'd get uplifting earthquakes and so on. You'd get volcanism. You get lots of little holes in the sphere spewing out this new matter, which of course creates further pressure and shoves the continents further apart.
Huh.
Okay, and what do we have on Earth now? Well, in the middle of every damn ocean, running between all the continents, is a big crack
Right.
from which we get expansion in the form of volcanoes and all kinds of stuff. There were a bunch of people up here at the U of W, University of Washington, that like in I think it was 69 or 70 had some ideas that eventually got funding, and in the late 80s they sent some ships down to the South Pacific looking for specifically for a volcano at a specific spot, because if they found this volcano under the sea, they figured that would be an evidence that indeed some of the expansion issues were more than theory. Well, they go there, and instead of one volcano, they found 11,000 volcanoes. And so, well, duh. And here's one last little capper on the whole thing. No geologist on the planet can point to any part of this planet and prove that subduction is taking place. And subduction must exist if the tectonic plate theory is accurate. And since we do not find subduction, we find something that is only inadequately explained as a subduction event and could in fact be explained much easier as part of the expansion process. So whenever they say that this plate is subducting under the other plate, that's mostly bullshit, simply because if you go and actually examine the data of what's going on there, they don't have any of the follow-ups to subduction. So in other words, if, for instance, we actually had subduction occurring at the San Juan de Fuca plate up here, where theoretically the Pacific plate is going underneath the American plate, then there would be a whole lot of stuff going on that does not occur. We have volcanoes here, but any place you have an active subduction fault must, by its nature, grind down matter to the point where it becomes liquid, hot, and magma again, and you must have volcanoes spewing out all over. What we actually find is the reverse. Every place that they say is a subduction event, you don't have volcanic venting. You only find volcanic venting where there are these boundary cracks between what we think of as the plate areas. And those boundary cracks are only on the sides of the planet where expansion is taking place. And we, by the way, if we were to have a subduction, we would never see the planet expand. And that is measurable now that it's actually occurred over these last 5,000 years. We actually are able to say, gee,